we have to design a data structure. We need to implement here anything, we have to design here the least recently used cache. This class we need to implement here. We have to implement, and also we are given this LRU cache function in which capacity is given. Capacity is also called the limit of the cache. Get function in which we pass a key and we will get the output value. We pass the key in this get function and we will get the value corresponding to this key. If if this key do not exist, then we return S1 here. And this is put function, put or push, whatever you call. We will push, by this function we will push both key value pair. Update the value of the key if the key exists. Otherwise add key value pair to the cache. Number of keys. The value of key exceeds the capacity. From this operation, evict the LRU key. To implement, they are also given to implement the get and put. All this function in a big O of one time. And these are the example as you are seeing, and these are the constraints given to us. The capacity going maximum to capacity or limit will take maximum value of 3000, and the key will take maximum 10 to the power 4 value, and the value will take 10 to the power 5. At most 2 into this much calls will be made by these two function get and put. So initially for this LRU cache we need 3 things to implement. We need the doubly linked list and the map, usually unordered map. So here, after the LRU cache class, we made this public, and inside this public we made the node class. Just after this public we made this node class, and in the public we are inserted some data. The data is our key and value, and the previous and the next node pointer, node star pointer, previous and next. And we have written the node constructor for this class node, and we have passed the key and value inside it, k and v as our input, and in this key and value from this data we have stored this k and v, which we have inputted into this node constructor, and we have initialized our previous and next with the null. And after the end of this class, I think this class, node class, we made the dummy head and dummy tail. Since we have made this dynamically, so we have used their new word and initialized the key and value both -1 for both of them, head and tail node. And we made the unordered map of integer, and this integer is key and the second pair is node star. This is integer limit, and we made the limit variable, which we will store inside the capacity of the LRU cache. Don't focus. We will then here void add node function. Here we pass the node star new node test code. These are the steps to add the new node. We have created the old next and initialized with heads next, and then we have written this 4 lines to add the new node, and then we have written the function to delete the node. And this is obvious, we have written this add node function. What it will do, it will add the new node to the doubly linked list. Okay, so that's why we have passed the new node. This new node will be added by this add node function. Add node will add the new node, and there is no loop in this case. So this add node function is implemented in constant time, bigger time. Similarly, this function is also here to delete the node. This is obvious, we have passed the old node. We will delete the old node. That's why we have passed here old node. Old node delete, and we will insert the new node. That's why we have written the add node, and we passed their new node. And we have written the 4 nodes, so 4 steps to delete the old node from the doubly linked list. And this is our simple LRU cache function given to us. Inside this, in this limit, the variable that we made just at the top, the limit variable. In that variable we store our capacity that we have passed here in the LRU cache function. We have passed as parameter the capacity that we are storing into that limit variable that we made above at the top. Let me erase this capacity. We are storing this capacity into that limit, that variable we made at the top just before this add node function, and just after this, before add node and just after this unordered map. Okay, now discuss the and this is obvious, heads next tail. This is the initial condition when we were having the 2 nodes, -1 -1 and -1 -1. This is head and this is tail. There was no other new node. We are forming the head and tail. We are connecting the head node with the tail node. So heads next will be tail and tails previous will be head. Simply, this is the initial condition, and this is a get function in which we pass key and we get the value corresponding to it. This is our base case. If we don't find the m.find, we have applied the find method. We have applied the check here. If we do not find m.find of key, is equal to m.n, means we have not found any key into this map, so we return -1. Note star, and these steps are written inside in my notes. Okay, these are the similar steps. And at the end, we return our answer. When we get value corresponding to key, then at the end we return our answer. This is put function. Look at code. This is also implemented in bibofn. Okay.